Semiconductors are all around us. As demands grow, manufacturers are motivated to create chips that will enable smaller, denser, and faster devices. DuPont's advanced packaging technologies enable the high performance and reliability required for today's applications. Today's chips use more transistors and create more heat, so they need more advanced thermal management. And millimeter wave deployment requires specialized materials to support the growing number of high-speed, high-frequency applications. Millimeter wave means a rising need for advanced packaging techniques like heterogeneous chiplet integration, since more RF and computing components are needed in small form factors. Many cycles of spin coating, photolithography, etching, and implantation are needed to create the transistors. This is followed by the formation of the metal interconnect layers to create the device. The dies are singulated, packaged, and mounted onto a circuit board. The packaging and thermal interface materials protect the delicate layering and dissipate heat. As demand for thinner, denser, and faster chips increases, so have the demands for packaging solutions. Traditional lead frame packaging evolved into pin grid array, then ball grid arrays, and now into system-in-package and wafer-level packaging. We've been increasing the number of transistors following Moore's law, but we are reaching the density limit. Modern devices require even more transistors, so designers are now looking to stack circuit layers vertically using very thin dies. Let's take a look at where and how DuPont materials are used to enable this new direction for chip packaging and assembly. Packaging dielectrics protect high-performance chips from mechanical shock, moisture, and provide the electrical insulation for the distribution wiring that connects the chip to the substrate or circuit board. Dielectric materials enable higher throughput, improved reliability, and higher density routing. Minimizing mechanical stress in the redistribution layers is increasingly essential to reliability. DuPont's metallization products are designed to meet the demands of advanced architectures and include copper plating for metal lines, pillars, through silicon vias, and dual Damascene interconnects, solder bump and pillar capping, as well as underbump metallization. New materials under development improve critical properties like lower cure temperatures and good thermal stability without impacting the low dielectric loss and low dielectric constant at millimeter wave frequencies. Cyclotene and Intervia dielectric resins support high-frequency applications and copper redistribution layers with excellent copper barrier and good thermal stability. DuPont offers metal plating photoresists that are ideally suited for wafer-level packaging applications. Designed to meet the tight dimensions, pitches, and varied topographies of today's advanced wafer-level packaging, these photoresists make it possible to print fine features with high aspect ratio and planarize over topography. They're easily removed after plating. Microposit SPR photoresists are well known in the industry for metal plating. Improved redistribution layer resists under development will enable even finer metal line plating with higher aspect ratio. Metal layers are electroplated on the wafer to form conductive pathways between circuits. Through silicon vias, or TSVs, are vertical electrical interconnects that allow dies to be vertically stacked. DuPont's production-proven copper electroplating solutions enable some of the most challenging TSV aspect ratios due to their high-purity copper, superior via-filling performance, fast plating speeds, and elimination of copper overburden. Our copper chemistries for redistribution layers enable patterns for fan-out wafer-level packages to meet next-generation line space requirements below 1 micrometer. They provide optimum plating uniformity, high purity, and good reliability. With so much function and performance packed into today's mobile and high-end computing devices, managing heat is more critical than ever. Thermal interface materials dissipate heat from the top of the dies through the metal lid and to a heat spreader. DuPont's specialized silicones achieve high heat transfer even in extreme operating conditions. Lid seal adhesives complement thermal interface materials to relieve the stress of managing the heat of high-performing devices through the heat spreader. They provide excellent primerless adhesion to substrate materials and perform reliably at high temperature, fast curing processing. They also perform well in stringent reliability tests such as temperature cycling and moisture sensitivity level testing. DuPont's thermal interface materials improve reliability and quality wherever they are used. Today's advanced electronics are expected to have more functionality in a smaller form factor with greater performance and reliability. Designed to meet the requirements of the Packaging Heterogeneous Integration Roadmap, DuPont's advanced packaging and assembly materials are valuable building blocks for today's advanced microelectronics.